I'd like to welcome Michael J. Zeher. He is a member of the senior technical staff at the Johns Hopkins University Applied Science Laboratory. He is the section supervisor for robotics and a project manager for the Revolutionizing Prosthetics and EOD Explosive Ordnance Disposal Robotic System Program. His work is groundbreaking. He works on programming robotic arms to move and react to human thoughts. Please welcome Michael Zeher to the podium.
Wow, this is exciting to be here with so many roboticists and so many robots. Very exciting. I want to thank the Professor Brzezina, the CSM faculty, and the organizers of the VEX competition for inviting me to speak today. The amount of hard work and dedication that this competition represents is very impressive. Today, the global ranking of our students in math and science is 25th in the world. There's a crisis for our nation. Thank you for being part of the solution. I commend you for that. So, how many of you stayed up all night? Let me see your hands. Anybody stay up all night? A few people have been up all night. How many people got 1 to 2 hours of sleep? 1 to 2 hours? There's some 1 to 2 hours. 2 to 4 hours? 2 to 4 hours? All right, how about more than 4 hours? All right, hey, that's good. So I think it's going to be a good competition. That's great. I want to talk a little bit about the exciting field of robots and robotics. Robots have been commonplace in our factories for decades, but now, in a Trends magazine report, a new generation of robots is also beginning to show up in homes, offices, hospitals, as well as in the battlefield. The more sophisticated robots are looking for snipers, minding children, caring for the elderly, acting as tour guides, and giving people baths and doses of medicine. Less advanced units are performing basic tasks like cleaning floors and mowing lawns. As with all digital technologies, the prices of robots are falling, while at the same time the capabilities are growing rapidly. Which country has the highest density of manufacturing robots today? That density is the number of manufacturing robots per 10,000 manufacturing workers. What country do you think has the highest number? China? Nope. Us? Nope. Japan. Who said Japan? Japan's the winner. That's right. Japan has 295 robots per 10,000 workers. Next in line is Singapore, then South Korea, Germany, Sweden, Italy, Finland, Belgium, and in number 9th place, the USA. We have 86 robots per 10,000 factory workers. Bill Gates was on Reddit doing a question and answer session this past Monday. He was asked this question: what emerging technology today do you think will cause another big stir for the average consumer the same way that home computers did years ago? He replied, robots, pervasive screens, and speech interaction will all change the way we look at computers. Robots was number 1. Robots are saving lives. They do dangerous work for us that we don't want to do. They're giving hope to those who have lost limbs. They also help us build our cars, manage our warehouses, harvest our food, and clean our homes. The field of robotics is a unique and dynamic field that's growing. So what about you in robotics? The field of robotics is unique compared to many other science and engineering disciplines because it's multidisciplinary. It's a wonderful blend of mechanical engineering, electrical engineering, software engineering, and systems engineering. This exposure will provide a huge benefit to you as you pursue your careers in science, engineering, and technology. Because of its multidisciplinary nature, there's another benefit of robotics that can be overlooked. That benefit is practicing teamwork. The more complex the system is, the more important teamwork becomes. As an example of this, I'm going to show you what Johns Hopkins Applied Physics Lab has been doing to help restore the loss of limbs for our wounded soldiers and those suffering from injury or disease, and how important teamwork is and was in accomplishing what 60 Minutes calls a breakthrough technology. The Revolutionizing Prosthetics program is all about creating a prosthetic limb that will be representative of the human limb. It'll weigh the same, it'll have the same force and power, and it will be neurally integrated into the patient's brain. There's been on this program over 30 different collaborators in industry, academia, and government. It's gone on for 7 years. It's in excess of $100 million. What it is all about is closed-loop cortical control of a prosthetic limb. So on the top, what we see is the patient is generating neural signals. Those neural signals are processed and decoded into motor control signals. The prosthetic limb has sensors on it. Those sensors will sense temperature, pressure, vibration. Those signals will get encoded and sent back to the patient and stimulate the brain so that they feel that pressure, that temperature. And that's the closed-loop cortical control. This is a picture of the modular prosthetic limb. We have it on display here, and at different times during the day, we'll operate it, we'll run it. Unless I get volunteers for brain surgery, we're not going to actually hook it up to a brain. We'll keep it simple today, but we will show you some videos. Here's the sensors in the hand. There's on the fingertips and in the palms, and these are multi-axis sensors that will capture an array of sensory stimulation. The wireless implants is the next step that we're doing. Currently, we have wired implants. That's in the upper left corner, and that is a 100 probe implant connected to a pedestal, and I'll show you a video in a minute of that. What we're doing now is working on making that wireless so that the wires don't come out of the patient's skull. So this is one of the first human subjects testing that was done. This is Tim, and we're going to run this video. Tim has been a quadriplegic at this point for 8 years, and he had what they call an ECOG array. It wasn't the electrodes implanted, but it was a sensory array that was placed under his skull on top of his brain. And he is thinking about moving his phantom limb, and what's happening is those signals are getting translated into the movement of the prosthetic limb. That's Tim's wife, and Tim hasn't been able to reach out and touch her for 8 years until now. Another human subject is Jan Sherman. She was the subject of 60 Minutes recently. And here Jan is able to, in just thinking about using what was her natural arm that she no longer has use of, she's able to control the prosthetic limb to do one of her favorite things, eating chocolate. You can see the pedestals installed on the top of her head. Pretty happy about that chocolate. Another way that we control the prosthetic limb is through surface electrical signals, EMG signals. And so here you see several different patients that have different levels of amputation, and they're able to control the prosthetic limb, and these patients are also getting sensory feedback. So what they have is they have their nerves on the surface of their skin integrated with the muscle, and those signals can control and they can also sense, just like you would in your brain, but they're doing it on the surface of their skin. So they don't get as much control as you do directly into the brain, but they still get enough control to be able to grab things, feel the pressure, and control things. So we take the prosthetic limb when it's not being used on patients, we look for other applications, and this is one of the other applications we have for doing dangerous tasks that we want to be able to be involved with, but we don't want to be there. So there's a remote operator, he's wearing cyber gloves and a stereo headset, and he's able to control the prosthetic limbs with the cyber gloves and sensors that he's wearing, and he's able to see. That's the view that the operator gets from a distance. And so he's doing this dangerous task of disarming this simulated explosive. And you can see the control that he's able to get through the high dexterity of this prosthetic limb. So he removes the detonator. And so that's some of the technologies that are growing out of this prosthetic limb development. So if you were careful to notice as we were going through those slides, you saw that there was always a team at work on this project. Teamwork is critical to implementing complicated problems and solving complicated problems. And what I want to do is propose to you a formula for success that I'd like you to consider. This formula for success is success equals teamwork, talent, and tenacity. I want to talk most about teamwork, but first I'll talk about talent. Work hard at your education. You need strong talent to quickly solve difficult problems. Build a good foundation in communication, reading, writing, and speaking, and work hard on your math and science. Tenacity is holding fast or being persistent. When you meet a failure, assess the situation, learn from that failure, and go for it again. Thomas Edison said, success is 10% inspiration and 90% perspiration. But the biggest multiplier in this equation is teamwork. Many talented teams can thrash and spin their wheels because they lack good teamwork skills. Improve your teamwork skills by doing 3 things. Take time to assess your own strengths and weaknesses. Be honest with yourself and evaluate your strengths and weaknesses. Honestly evaluate your team. Assess their strengths and weaknesses, and find the role on your team that will make the biggest contribution, even if it's not what you most want to do. And then third, respect the authority structure of your team leader and your advisors. To the team leaders, I would say communicate the goals to your team. There's a primary goal that's made up of many minor goals that lead to the end. Clearly articulate those goals as they evolve and change. Lead by example. Depend on your team to find solutions. Listen first, then take action. So in conclusion, I wish all of you the best today. There will be winners, there will be losers, but with the proper attitude, everyone can have fun. So have fun, think about your teamwork skills, and be excited knowing that you're part of the very exciting field of robotics. Thank you.